Okay, we're going to be talking about Chapter 26, the skeletal and the muscular systems. Muscles interact with the skeletons. Okay, movements require interaction. Basically, a muscle has to be attached to one bone to move another bone. Okay, the skeleton adds a firm supporting structure, and it provides, the muscular system provides muscle cell contraction, which provides movement. Some muscle is voluntary and some muscle is involuntary. Different types of skeletons in the animal kingdom. Hydrostatic skeleton, things like jellyfish, earthworms. Basically, they have a fluid-filled cavity that they can tighten the muscles around to provide a hard area to push their muscles against to propel themselves. Then you have exoskeletons, like this crab. Okay, exoskeletons are made of a substance called chitin, C-H-I-T-I-N. And then you have the endoskeleton, which is like us vertebrates have. Okay. The axial skeleton and the appendicular skeleton are our two divisions in humans. The axial skeleton is the skull and the vertebral column. And then the appendicular skeleton is made up of the appendages. So you have the pelvic girdle here, the pectoral girdle bones here, and then the arms and the legs. Okay? So we're pointing here, these three things make up the axial skeleton. Skull primarily protects the brain and the sense organs. Ribs protect the heart and lungs. And the vertebral column protects the spinal cord. These are all very important functional parts of the human body. The appendicular skeleton is the stuff here in blue. And it's your appendages, your pectoral and pelvic girdles, and your arms and legs. The vertebrate skeleton consists of a lot of bones. I think somewhere around 208. You're not going to have to learn that many, so don't freak out. Bones are lightweight and strong because they're porous and not solid. Bones consist mostly of specialized cells suspended in a hard matrix. Okay, now this is a femur, and the femur, this would connect up to your pelvic bone, and this would articulate and be part of the knee joint. You have this area in here, the hollow part, that would be filled with marrow. All of this porous bone in here, we call it spongy bone because it looks like a sponge close up. It's covered with a thin layer of endothelium. There are blood vessels moving throughout all of your bones, and these little white streaks are called your growth discs, but they've hardened. So this is an older individual who has finished all of his growth. When you are still growing, you have cartilage in there, and cartilage grows and makes the bone taller, and then it is reshaped and remodeled and turned into hard bone. Okay. Here's the bone structure and function. In the compact bone, the solid bone, you can see that here, and on the outside. It's made in these little circular arrangements called osteons. Osteons are made, they follow in a pair of blood vessels, an artery and a nerve, and they have special cells, okay, that lay down bone matrix. And you can see all of these little dashes, what looks like dashes. Those are called canaliculi, or little canals. And this is called the central canal. And all these little canals also have blood vessels through them. The cells that make this stuff, that makes bone matrix, are called osteoblasts, with a B. Okay? And here are some cartilage cells. Now, on the ends of your bones, you will have cartilage cells. And then you'll have marrow. There's two types. Yellow marrow is just a fat storage. And red bone marrow is where we make our new blood cells and platelets. Red blood cells, we don't undergo mitosis. They don't have a nucleus, so that they can carry more oxygen. And so they have to constantly make new cells. Okay, there's two things that make up bone: collagen fibers and these things called hydroxyapatites. They're just minerals. These two things together are very, very strong. Apart, they're not. You can take a bone like a chicken bone and put it in vinegar or a weak acid, and it will slowly dissolve the minerals, and you'll get a rubbery, bendy chicken bone. Or you can take a bone and put it in the oven at very high heat for a certain amount of time, and it will vaporize all the collagen fibers, and then when you come out, if you touch the bone, it'll just fall into a little pile of ash because the collagen's gone. There are nerves and blood vessels in here, and that's important because if you break a bone, you need the blood vessels to bring the raw materials necessary to repair the bone. Collagen does give flexibility. The minerals add rigidity. Compact bone is hard and dense. Spongy bone is light and porous. And so basically by using spongy bone and this cavity in the medulla of the bone, it lightens our bones, makes them not quite as heavy. The vertebrae and skeleton also has, the vertebra skeleton has cartilage in it. Now, how does this work? Okay, I found a little animation I want to show you of how these osteons are formed. Let me pull it over here. And so here is an osteon being formed, and this is the central artery bringing blood and resources to the area. And you have little cells called osteoblasts that slowly lay down bone matrix around the blood vessel. They eventually meet. Okay. And then they'll start making more layers. And that's how you form an osteon. Now this progression shows the development both embryologically up to the fetus stage, the newborn, a child, and an adult. Children have open growth plates, okay, so that they get taller. Now, you start out with just a hyaline cartilage model of your bones as an embryo, then as a fetus. By the time you are born, you've got some bone, and what happens is blood vessels grow into the cartilage, and then osteoblasts start replacing cartilage with bone cells and slowly shaping and remodeling. And I've got a little example here. Let's see what it shows me. So there's a fetal bone here. It's still in the fetal stage. And blood vessels are growing into this hyaline cartilage. Okay. And it starts with like a little collar around the outside here. Okay. Right here is where you get your collar. And so it makes this part of the bone first. And then osteoclasts, spelled with a C, osteo, which means bone, O-S-T-E-O, clast, C-L-A-S-T, starts destroying and building this medullary cavity to lighten the weight of the bone. And these areas where they're laying down bone matrix are called ossification zones. Okay. Then more grow into the ends and start ossifying up there. And they'll leave a little growth plate of hyaline cartilage that will allow you to grow taller. Okay. Now, on the outside of the bone, you have articular cartilage. Okay, and so where two bones articulate or grind together, there's this hard rubber hyaline cartilage that kind of protects them. So if we look at a skeleton like this, all of these surfaces that interact with another bone are covered with hyaline. Okay, here's a summary of the functions of bone. Support provides the animal's body against, supports the animal's body against gravity. Provides the shape. Movement, it is attachment points for muscles. You have really important internal structures that are protected by layers of bone. It makes blood cells and mineral storage. Mineral storage is where your body uses calcium and phosphorus ions for various processes physiologically. And so if there isn't enough calcium in the blood, you have little cells called osteoclasts. That's spelled with a C, osteo, C-L-A-S-T. And they break down bone and dissolve it and harvest those calcium ions. And then when you eat food that has calcium in it, they lay down new matrix. Osteoporosis or osteoporosis. Normally, bones are a reservoir and you're constantly dissolving and making new bone. This is very important. And your bones get stronger the more you exercise and the more activity you have. The less you exercise, the less activity, the weaker they will get. You can get weak bones just by becoming very sedentary. So you need to develop those habits now so that as you get older, your bones don't become weak and brittle. Okay? Now, there is a disease called osteoporosis, weak bone. As you get older, you will basically tend to dissolve bone faster than you'll make new bone unless you are stimulating the bone to generate a lot of new bone growth. All right? And here is some osteoporotic bone. This can get so bad that just stepping off of a curb can cause you to break a bone. This is especially bad in women because estrogen plays a role in bone formation, and as women get older, they produce less estrogen, and there are several ways to address that with creams and oral supplements and things like that to increase your estrogen levels. Bone meets bone at a joint. A joint is just an area where two bones meet. Now here's the end of two bones, and they're both covered with this what is called articular cartilage so that they rub together smoother, and then there is this layer of capsule all the way around, and there's fluid in there. Okay? And the fluid is kind of thick, but as you warm up, it's like oil. It gets thinner, and it helps reduce friction, and so it causes less damage on the bone. It works basically just like motor oil. It's called synovial fluid. And some joints are far more movable than others. Your knee joint is your most flexible joint, and that's where you get a lot of knee injuries because the more flexible and the more movement it can do, the less strength it has. Okay? Ligaments and tendons. Tendons are used to connect bone to muscle, while ligaments connect bone to bone. That wraps up part 1 of chapter 26.